myself H.S. Ahmed, Assistant Professor, Department of Physics, St. Francis De Sales College, Seminary Hills, Nagpur. So, I am going to present this topic, feedback in amplifiers. Now, what is feedback? Feedback is a process of taking a part of output from a circuit and applying it again to the input of the same circuit. So, this process of taking out a part of the output and giving it back again to the input is called as feedback in amplifiers. The feedback is said to exist in a circuit when a fraction of the output signal is returned or fed back to the input terminal and combined with the input signal. Feedback principle was first proposed by American electrical engineer Harold Stephen Black in 1934. So, feedback is a process of injecting a part of energy from the output and return it back to the input. The amplifier which uses feedback principle is called as feedback amplifier. Now, this diagram shows the feedback amplifier. So, a feedback amplifier is the combination of the amplifier as the feedback network. So, this is amplifier to which we can apply an input. So, it is going to give us some output. Now, a part of that output is fed again back to the input through this feedback network. This feedback network can be the combination of some resistance, capacitance or some passive networks. So, this Vf amount of output, part of the output Vo is captured and again it is fed back to the input, so that it gets combined with the original input. The effective input becomes Vi dash. So, this now new input Vi dash, which is the sum of this Vi plus Vf, is amplified by this amplifier. So, this makes the feedback amplifier. So, there are different types of feedback. Basically, they are classified into two main categories. One is positive feedback or regenerative feedback. So, if the feedback signal is applied in such a way that it is in phase with the input signal, so that its magnitude increases, it is called positive feedback. So, although positive feedback increases the gain of amplifier, however, it introduces excessive distortions in amplifiers, hence it is not very popular. Positive feedback is rarely used, positive feedback is essentially used in oscillator circuits. Second kind of feedback is negative feedback or degenerative or inverse feedback. If the feedback signal is applied in such a way that it is out of phase with the input, so that the magnitude of input voltage decreases, it is called negative feedback. Although negative feedback reduces the gain of amplifier, it improves the performance of the amplifier in many other aspects like reduced gain, enhanced bandwidth, enhanced gain stabilization and so on. Let us try to understand the general theory of feedback in an amplifier. So, let us consider an amplifier without feedback. So, this is an amplifier without feedback. Vi is the input and Vo is the output. So, gain of this amplifier is A is equal to Vo upon Vi. This is the gain of the amplifier without feedback. Now, suppose a feedback loop is added to this amplifier. So, this is the diagram. Here, this is the original amplifier, and to this amplifier a feedback network is connected. So, what this feedback network do? Whatever output is there, a part of that output is taken and that part or fraction of the output is again fed back to the input of this amplifier. So, here Vi is the original input without feedback and Vo dash is the output of this amplifier with feedback. So, a part of this output is that fraction is beta is taken, so that the feedback voltage Vf is equal to becomes beta times Vo dash. So, this much voltage Vf is taken from the output and it is fed back to the input through this feedback network, so that new input Vi dash becomes Vi plus minus Vf. Now here this plus minus sign indicates whether the feedback is in the same phase with the input or it is not in the phase, right. So if it is in the same phase, show that total input gets total input enhances. So in that case it is the plus sign. So in case of positive feedback, the sign will be positive, and if it is of the negative type feedback, then it is will be of negative type. So plus minus indicates whether feedback voltage is in the phase or out of phase with the input voltage respectively. So Vi dash is equal, if we consider this here in this case, this is the positive type of feedback. So definitely it will be in the same phase, that is output voltage which is fed back to the input, it is in the same phase to the input. So what will happen, the resultant input Vi dash will be Vi plus beta times Vo dash. This input voltage will be amplified by this amplifier again by gain times. Hence the output voltage with the feedback is Vo dash is equal to A times Vi dash. So output voltage Vo dash is equal to A times Vi. In place of Vi dash we can substitute the value, so that Vi plus beta times Vo dash. So we can open the bracket. So A Vi plus A times beta Vo dash. So here this terms, beta term can be sent to left hand side, so that we can take Vo dash common in the left hand side. So left hand side becomes Vo dash times 1 minus beta A is equal to AVI. This Vi can be sent to the left hand side, and 1 minus beta A can be sent to the right hand side, so that this expression becomes Vo dash over Vi is equal to A upon 1 minus beta A. Now this ratio Vo dash over Vi is nothing but the closed loop gain, or the gain of the amplifier with feedback. So thus gain of the amplifier with feedback becomes A upon 1 minus beta A. So this is the gain of the amplifier with feedback when the feedback is of positive type, right, where the input total input enhances after the feedback is given to it. So this is the expression for the gain of the amplifier with positive feedback. Now if we consider that in the same amplifier we are applying the negative feedback, where the output taken is fed back to the input in the out of phase. So what will happen, the overall input will get decreased. So if we consider that the output to the input is fed out of phase, that is the case, it is the case of the negative feedback, then overall input becomes Vi dash is equal to Vi minus beta times Vo dash. And in that case the expression, overall expression for the gain, if we proceed in the same way, we can show that the gain of the amplifier with feedback in case of negative feedback becomes A over 1 plus beta A. Now discussion. So if 1 minus beta A, now you should remember 1 minus beta A is nothing but the quantity in the denominator of that positive feedback. So if that quantity is greater than 1, then AF is less than A, that is its meaning is gain of the amplifier with feedback is less than A. So it is called as the negative feedback, right, it is the case of the negative feedback. So or inverse or degenerative feedback. In this case, although gain decreases, but it improves the performance of the amplifier in several aspects, like increased gain stability, increased bandwidth, increased input impedance, decreased output impedance, decreased noise, and so many advantages are there. So in case of negative feedback, there are various advantages. So therefore it is employed in many amplifier circuits. Now if 1 minus beta A, that quantity 1 minus beta A is equal to 0, under that case beta into A is equal to 1. So, definitely that will be is equal to 1, and gain of the amplifier with feedback becomes infinite. So, it means that the circuit is able to provide the output even if there is no input present at its input. So, this is the case of actually the oscillator, in which we do not apply any input, however, still the circuit is providing the periodically varying output signal or the voltage. As a third case, if 1 minus beta A is less than 1, then gain of the amplifier with feedback will be greater than A, and this is the case of positive feedback or direct feedback. Again, in this case, although gain increases, however, it introduces a lot of distortions, or the circuit becomes unstable, and it introduces this case introduces instability in an amplifier, and therefore usually it is undesirable. So, positive feedback is usually avoided. So, there are various advantages of negative feedback. So, in case of negative feedback, although gain is decreased, however, gain is stabilized. So, gain does not change frequently. So, therefore, one advantage is gain is stabilized. Second is increased bandwidth, the range of frequency to which the amplifier can amplify improves. So, frequency response improves. Then enhanced input impedance increases. So, loading effect is avoided. Then reduced output impedance, again here the output impedance of an amplifier should be as small as possible to transport the maximum power. So, the output impedance really decreases in case of negative feedback, and therefore it is good. Then higher fidelity. So, more linear operation is there, then less harmonic distortion, then less phase distortion, less amplitude distortion, less frequency distortion, and reduced noise. So, these are various advantages of this. Now, as a example, let us consider in a negative feedback amplifier, A is equal to 100, beta is equal to 0.04, and Vi is equal to 50 millivolt. Find gain with feedback, B output voltage, C feedback factor, D feedback voltage. So, gain of the amplifier with feedback in case of negative feedback is given by this formula. So, A is given, beta is given, and therefore gain of the amplifier with feedback can be calculated by substituting. So, it comes out to be equal to 20. Now, output voltage, gain of the amplifier with feedback can also be written as output voltage with feedback divided by whatever is the input. So, from that input voltage here it given as 50 millivolts. So, output with feedback becomes feedback gain, gain with feedback, and input voltage. So, that comes out to be this much, 1 volt. Then feedback factor is beta into A, beta is given 0.04, A is also given. So, this becomes 4. Now, feedback voltage is feedback fraction times the whatever is the output voltage with feedback. So, feedback fraction is 0.04 and output voltage is 1 volt. So, it comes out to be 0.04 volts. So, this is the. So, thank you very much.